Welcome back. This is our second lesson in Unit 2, and this lesson involves linear equations. In this lesson, we will be identifying linear equations and functions. We will be writing those linear equations in standard form, and we will also be graphing the linear equations by finding their intercepts. So first off, we need to figure out how do we identify linear equations and functions. Well, in order to be a linear function or a linear equation, the variables can only be added, subtracted, or multiplied by a constant. They can't be multiplied by each other. It has to be a number. So you have a variable and a number that are either added, subtracted, or multiplied. No variables can be multiplied together, so things like x, y, that would not be linear. And the only exponent on any variable is 1. That's the highest exponent you can have for it to be linear. We also can't have variables in the denominator, and it has to graph as a line. So here are several examples of linear equations. All of these are linear equations. They all have variables that are either added, subtracted, or multiplied by a constant, and none of the variables are multiplied together by each other. Here are some examples of equations that are not linear. This one is not linear because it has an exponent of 2. This one has a square root, a radical, and that makes it a different exponent if we were to write that exponentially. This one has variables multiplied together, and this one has a variable in the denominator. So those are not linear. In our last lesson, we learned that linear equations could be written using function notation by substituting this f of x for y. And in that lesson, we learned that in order for it to be a function, every element in the domain had to correspond to only one element in the range. So we want to determine in this lesson whether the function is a linear function. So based on the definition that I just gave you, can you tell whether or not these are linear functions? So over here, letter A, we have the highest exponent is 1. This is a yes. This is a linear function. This one has an exponent of 4. That's a no. And then down here, letter C, we have h of xy is 2xy. That's a no because those two are multiplied together. We can't have variables multiplied together. So we also want to learn how to evaluate linear functions. So suppose I have an equation up here that tells you how the depth in the water is related to its pressure. So we have a linear function saying the pressure is 62.5 times the depth plus 2117, and it helps us find the pressure in pound per square feet, d feet below the surface of the water. Find the pressure at a depth of 350 feet. Well, all we're going to do is instead of d, we're going to plug in the number 350 in the equation. So we're going to find P of 350. And P of 350 is just 62.5 times 350. Take that answer plus 2117. That gives us 23,992. Now this term, 2117, in that function, what it actually represents is the atmospheric pressure at the surface of the water when the depth is 0. If you put in a 0 right here for D, you would get P of 0 is 2,117. So that's what that represents. The question is, how many times as great is the pressure at a depth of 350 as the pressure at the surface? Well, here's the pressure at the depth of 350, and we know the pressure at the surface is 2117. So all we need to do is to go ahead and take those two numbers and divide them, and we will find how many times greater the pressure is. It's about 11.33 times greater. So our answer to that question would be 11.33 times greater is the pressure at that depth. Standard form of a linear equation, you've probably seen this before, is ax plus by equals c. A, B, and C are numbers. They are actually integers, and those integers have a greatest common factor of 1, so they can't have a multiple of another number, so they have to be in reduced form. And we also can't have A and B can't both be 0. So our example here is to write each equation in standard form and then identify what those coefficients A, B, and C are. So let's go ahead and work out a couple of these problems. So first up we have y equals negative 2x plus 3. So remember we want to get x and y on the same side, so I would add 2x to both sides. And then remember to keep your equality sign lined up. These cancel on the right, and I only have a 3. And I'm going to put my x term first. Oops, that looks like an x. It should be an x. So I have 2x plus y is equal to 3. So A in that example would equal 2, B would equal 1, and C would equal 3. Okay, so that's standard form. Let's take a look at one that's a little more difficult. Let's look at letter B. Now letter B, one other thing I forgot to point out, A has to be greater than or equal to 0. You can't have a negative coefficient for your first variable. So we'll see that in example B here. So this one I just need to bring the y term over, so I'm going to subtract 3y from both sides, minus 3y. And remember the x terms and the y terms are different, so they stay separated. So I have negative 3/5 x minus 3y is equal to negative 2. These don't combine, okay? And I want to put the x term first. Now, an integer is a whole number, so I can't have any fractions. So what I need to do in order to put this thing in standard form is I need to get rid of that denominator, and I also can't have this negative right here. So I'm going to multiply by negative 5, and I'm going to just distribute that through each term. So negative 5 times negative 3 would be a positive 15, and 15 divided by 5 is 3. So that would be a 3x, and a negative times a negative in the next term will give me a positive. So negative 5 times 3, negative 5 times negative 3 is a positive 15, and then we have our y term. And then negative 5 times negative 2 is positive 10. So in this one, A is equal to 3, B is equal to 15, and then C is equal to 10. And I have two problems for you to try right here, C and D. Pause the video, do those, and then bring your answers to class. Another thing we wanted to learn in this video is how to graph linear equations by finding the intercepts. And an intercept is basically where the graph crosses an axis. To find where that crosses the axis, or to find that intercept, we just let the opposite variable be 0 and then solve it. So our first example says find the intercepts of the graph. 3x minus 4y plus 12 is 0, then graph the equation. So what we're going to do is we're going to let, for the x-intercept, we let y be 0. For the y-intercept, we let x be 0. So we're going to let y be 0 right there. So we get 3x plus 12 is equal to 0. And then subtracting 12, we get 3x is equal to negative 12. And then dividing by 3, we get x is negative 4. So this is the x-intercept. This is where it crosses the x-axis. Over here to the left at negative 4, we could make a dot. 1, 2, 3, 4. We could make a dot right there. And then the next one, we let x be 0 to find the y-intercept. And that one gives us negative 4y is equal to negative 12. Dividing by negative 4 gives us y equals positive 3. So up here at y equals 3. So if we connect those two dots with our intercepts, we can draw the line. We only need 2 points to determine a line, if you remember from geometry, and that's the line we get. So the next two slides have practice problems for you to do. All of the content has been explained in the video, so go ahead and read through those and go ahead and do each of those problems and bring your answers to class, and we can talk about those in class. See you next time.